Unit 9, Day 1 notes. Today we'll be discussing polygons and their angles. A polygon is a closed plane figure formed by 3 or more line segments. So examples of figures that are not polygons would include something like this. A circle is not a polygon because a circle is not formed by line segments. That figure is formed by line segments, but it doesn't close, so that's another example of something that's not a polygon. So again, or even a simple angle is not a polygon. Again, it's not closed and it doesn't contain 3 or more segments. Not only do we have polygons, but polygons could be both convex or concave. Convex means that all vertices point outwards. And also, I should be able to form a diagonal, which simply means from vertex to vertex. And all diagonals are going to be in the figure of a convex polygon. So all these diagonals are inside the figure. A concave is just the opposite of all that. One or more vertices point inwards, forming a cave in the shape. And if I were to connect the diagonals, like here, notice that diagonal is outside the shape. So again, a diagonal is connecting vertices together, and these diagonals will be outside the shape. So another reason why it's concave. Now we're going to name polygons based on how many sides they have. A couple of names you should be familiar with. A three-sided polygon is, of course, a triangle. Oh my goodness. Four-sided figure we just got done talking about, but it's a quadrilateral. Five-sided would be a pentagon. Six-sided would be a hexagon. Seven-sided would be a heptagon. 8, come on, what's that stop sign? Octagon. A nine-sided polygon is a nanogon, I believe. Ooh, I'll be back on that one. 10-sided is a decagon. 11-sided is a decagon, I believe. And a lot of these higher numbers have some fancy names for them, some of them. I know 13, we just start saying 13gon. 25 would be a 25gon. And for any number of sides, we can just say an ngon. But again, definitely the first 1, 2, 3, 4, 5, 6 you should know by name, as well as number 10 you should know by name. Again, I'll come back on the number, not the 9-sided figure. I can't recall it right now. What is a regular polygon? So now not only do we have to classify it based on whether it's convex or concave and the number of sides it has, but it can be regular or irregular. And a regular polygon is one that has all congruent sides and angles. So both congruent sides and angles. For an example, an equilateral triangle is a regular polygon because all three sides measure the same. That's why it's equilateral. But all the angles will be the same measure too. And so it's also equilateral and equiangular. So that's another way to look at a regular polygon, the definition. And then a square is also a regular polygon because all four sides are congruent. Always, always, always. And then it has four right angles. Now let's talk about interior versus exterior angles. Interior angles are all angles within the, the sides or the walls of the figure. So you have one interior angle here, you have another one here, you have another one here, and so on and so forth. And the number of interior angles is determined by the number of sides. So this figure has 1, 2, 3, 4, 5, 6, 7, 8 sides. So that means it has 8 interior angles. So again, the number of sides will determine the number of interior angles. Now, an exterior angle is all the angles that are outside the figure, but they form a linear pair with the interior angle. So if I take angle 6 right here and the side that it's attached to and extend it out, there would be an exterior angle right here. So we could call that angle 9. And again, it's the same amount of interior angles. For every interior angle, there's an exterior angle. So there's going to be a 10th one here, there, and again, it's always a linear pair with the interior. I should have made that a little straighter. Okay. So interior will be inside the figure. So inside the walls. And exterior will be outside the walls. So all of this is considered interior. And then all of this is considered exterior. Now we're going to get into more depth and hopefully develop a pattern to determine the sum of the interior angles and the measure of an interior angle. So in order to do that, let's take the triangle first and foremost. And we're going to draw the diagonals of the triangle. So the triangle doesn't have any diagonals. So it's just going to stay 0 diagonals. However, we know that Oops, let me undo that. We know that this, no matter what the angles are, if we find the sum, that it'll equal 180 degrees. So a triangle has 3 sides, and it's one triangle, and the sum will be 180 degrees. Now, if I take 180 to find the measure of one interior angle, we're looking at regular polygons only. So that means all the angles would be the same. So if I take 180 and divide by 3 to get the same measure, I would get 60. So each interior angle will be 60 degrees. Now let's find the sum of the exterior angles, and at least one. So again, to find an exterior angle, you extend the side and it'll be the linear pair with the interior. So we already said the interior was 60. So what would need to pair with 60 in order to produce 180? That's right, we would need 120. So that means one exterior angle is 120 degrees. So if I were to take that 120 and extend here, this one would also be 120. And extend here, this one would also be 120. And add those up, you would have a total of 360. So the sum of the exterior is 360 for a triangle. Now let's take the quadrilateral and draw the diagonals. So when I draw a diagonal, it splits it into 2 triangles. So again, we know that each triangle has 180 degrees in it. So there's 180 degrees over here, and then there's 180 degrees over here. So together, what's the grand total? 360. Now, if I have 360 degrees and I'm looking at a regular quadrilateral, so I would have to take that 360 degrees and divide it by 4 to know the sum of, to know how much one interior would measure, and it would be 90. So one interior would be 90. Now let's find one exterior. Again, if you extend this side, you know there's 90 over here. What would pair up with 90 in order to produce 180? It would have to be another 90. So one exterior angle is 90. So you would have another 90, which is 180, another 90, 270, and another 90, 360. So the sum of the exterior is 360 again. For a pentagon, it has 5 sides. And let's see how many triangles can be formed when I draw the diagonals on a pentagon. 1, 2, 3. So there's 3 triangles. So that means it's 180 plus 180 plus 180. So that means it's 540. And so I would take 540 divided by 5 to figure out the measurement of the interior. you get 108. So each interior angle measures 108 degrees. And now let's find one exterior. No, that's not a good one. I didn't draw a good one there. Sorry. Alright, so here's one. Alright, you already know this is 108. And 108 would need to pair with 72 in order for it to equal 180 together. And then again, if you find all 5 72s, in other words, 72 times 5, you would get 360 degrees. So far you should be able to see some patterns. And we're going to use that to help us figure out the next line. Alright, so a hexagon is 6-sided. The number of triangles, let's predict it's going to be 4. 1, 2, 3, 4. So it would be 4 times 180, because 1 times 180 was 180, 2 times 180 was 360, 3 times 180 was 540, so it's 4 times 180 this time. So 4 times 180. And that would be 720. So 720 is the sum. If I take that sum and divide it by 6, it'll tell me the measure of each interior for a regular. So divide this by 6, and I get 120 is each regular interior angle. The sum will be 360, and one exterior angle would be 60. Again, one interior and one exterior should be a linear pair. They should add up to be 180. So that's a reference right there. It was a nonagon. I was right. And a dodecagon for 11. So, the purpose of the table was to derive these formulas. And you need to remember these formulas. N represents the number of sides the shape has. So to find the sum of interior angles, you're going to use the formula 180 times the number of sides minus 2. To find one interior angle, you're going to take 180 times n divided by, or n minus 2 divided by n. In other words, what that is saying, I know it looks like a lot of algebra, but what it's saying is essentially you're taking the sum of interior divided by the number of sides. And to find the sum of the exterior angles, it will always, always be 360. Always, always, always. And to find one exterior, you take 360 divided by n, or you can take 180 minus the interior. So it depends on what information you have. Let's do some sample problems. Number 1 wants us to find the sum of the interior angles of a convex 17-gon. So again, the sum of interior formula was 180 times n minus 2. So that means 180 times n, which is 17, because it's a 17-gon, minus 2. So that's 180 times 15. And now we grab our calculator. And you get 2,700. All right, the next one wants us to find the measure of one interior angle of a regular 32-gon. So in one interior was equal to 180 times n minus 2 over n. So that means 180 times 32 minus 2 over 32. In other words, 180 times 30 over 32. So now let's grab our calculator. And on your calculator, you can type all of this in one step. So you could have 180, open parentheses, 32 minus 2 over 32. And that's probably best just in case you make a simple arithmetic mistake. And you're going to get 675 divided by 4. So actually carry that out. Oh. Let me actually divide it. I don't want it as a fraction this time. Go back. Delete. Delete. Clear. Alright, 6, 7, 5 divided by 4. And you get 168.75. Alright, find the sum of the measures of the exterior angles of a 27-gon. The sum of the measures of exterior is always 360 degrees. Find one exterior angle of a 16-gon. So what you can do for this one is for one exterior, the formula was 360 divided by n. So that's 360 divided by 16. Grab our handy dandy calculator. $22.5. degrees. Boom. Forgot my degree symbol. Gotta have that degree symbol. Number 5 says how many sides, so we're looking for n this time, does a polygon have if the sum of the measures of the interior is 5580? So we're looking for n, but we know the sum of interior formula is equal to 180 times n minus 2. And we know that the sum is 5580. So we're going to put that on the left side of the equation. Now, there's several ways of doing this. What I would do first is divide both sides by 180. And you're going to get a number. So it was 5580 divided by 180. 31. So now we have 31 is equal to n minus 2. And then using your algebra skills, you got to add 2 to both sides. So you would get 33 is equal to n. And you could always go back and check your answers, plugging in 33 for n into the original equation to make sure it gives you 5580. Now number 6, again, it's asking for how many sides does a regular polygon have if one interior angle has a measure of 162 degrees. So this is another one where there's a lot of different ways to solve it, but I'm going to go with my first gut here. And we know that one interior angle, the formula is 180 over times n minus 2 over n. Okay, so we know what one of them measures, and that's 162. Now you can put 162 over 1 and cross multiply and solve for your n that way. Another way that you could do it is that we know that exterior and interior should add up to be 180. So if you recall, the exterior formula is pretty simple, or it's less complicated because exterior says 360 over n. So it's going to have n in less places and it'd be easier to manipulate. So what we're going to do is, if we know that the interior is 162, what would the exterior need to be? 180 minus that, which would be the exterior would equal 18. So since I know the exterior has to equal 18, and I know the exterior formula is 360 over n, doesn't that look a little easier to manipulate than the original one I had in red? So that might be a strategy that you should use. It's less complicated and it less room for error. So I would use this one if I were you. So again, we're going to cross multiply. And after we do that, you would have 18n is equal to 360. And divide both sides by 18. And you would have n is equal to 20. Which again, you could have found, you still would have gotten 20 if you finished where I had started going. It just would have taken you a couple extra steps. And lastly, number 7, again, we're looking for the number of sides. We have one exterior angle that is 5.625 degrees. So I've already did an example that had to deal with one exterior angle. So you can solve that one on your own. This concludes your notes for today.